Hey, I just wanted to take a few moments and talk to you about Advent of Code. If you've not heard of Advent of Code before, it is something that I've played around with a couple of times. Spent a lot of time in 2021 and not so much in 2022, but I'm very excited for Advent of Code 2023 this year. It's something that I've had my eye on all year, and I'm excited to get started with. So, what is Advent of Code? Advent of Code is a code calendar leading up to the 25 days of Christmas. First, let's talk about what an Advent calendar is. An Advent calendar is a calendar of events or things to do leading up to a particular milestone or holiday. So typically, you'd have something like an Advent calendar for Christmas. You can look those up. Let's say Christmas Advent calendar. And this is just some fun things to do leading up to Christmas. We can dive into some of these details. Not really going to do that, but typically these are physical items. Some people have presents. Maybe you get a different piece of chocolate each day. Advent of Code is a 25-day calendar event leading up to Christmas where each day is a new puzzle. So each puzzle unlocks at midnight, starting December 1st at midnight. So November, 30th, 31st, whatever the days in November are, that midnight you will have your first, as soon as December 1st opens, you'll have your first code dropped. So this is really exciting because it gives you an opportunity to hone your skills, to program and develop, and you can learn new languages, or just hone your skills in a language you like. So I prefer Golang right now. I'm doing a lot of work in Go, and so I like to sharpen my skills, hone them, and do some problem solving. So I intend to attack Advent of Code this year, working on it Advent of Code this year, and I'll start December 1st. And I don't plan to try to get on the leaderboard or anything. The idea is that I'll pick that puzzle up, I'll look at it, I'll read it, and I'll try to solve it. And so I'm going to be building an Advent of Code repository, and I'm going to use Cobra to help with that. And that way we can create different things for different days. And I intend to use some TDD or test-driven development along the way. So I'm going to start preparing for Advent of Code now. There's a couple of concepts that I want to share. So if you go to the events, and I'm going to go to 2022, as you can see, I only did one last year, and then I kind of got really busy, but I really intend to hammer it out this year. If we take a look at this one here, the most recent test or puzzle, this was for day 2, so December 2nd of 2022. And so what's kind of cool about Advent of Code is you have a story, some sort of backstory. Usually this has to do with Santa or elves and their preparation for getting their gifts to and from a house or creating them. And in the past, they've had some where you're in a submarine or you're creating different programming tasks. And so I'm going to dive into these as we go, but I'm just going to share one here. I'm not going to read through this one today, but the basic concept is you get some sort of text file with some sort of inputs. So in this case, A, Y, B, X, C, Z. Each of these are representation of rock, paper, scissors. A, B, and C is player 1, Y, X, and Z is player 2. And depending on who wins in rock, paper, scissors, will output the value. So in this case, rock is A, paper is B, and then scissors is C. And then for player 2, Y, X, Y, and Z. So Y is paper, X is rock, and Z is scissors. And so based on which numeric value you choose will indicate the scoring. So we can create some sort of methods here that, given 2 sets of inputs, what the data is. Now, what's interesting about this is that each person gets a different puzzle input, and their answer is dependent on that input. So it's going to be different for everybody. And so that's what also makes it challenging, is that even though we can solve it the same way, because there's different inputs for different people, the variations on this might be slightly different. So if I want to look what the actual input looks like, you can see it's just a plain file starting out with a letter, multiple lines, a letter followed by a space, followed by a letter. So if I look at this input here, that's very similar, and we can grab that. So what's the cycle for this? Well, each day has an input file, and if you look at the URL, you can see that there's a common way of getting that data. So that's great news. So we can create some sort of method up for like fetching this data very quickly. But before I do that, I just want to just simply look at what we can do from a test-driven development perspective. So I typically don't start with TDD with a lot of the things that I do in the real world. I find while you can do TDD from the beginning, it sometimes makes things a little bit challenging to think in the abstract. So I typically start building, and then as I build, I start iterating with some tests. And then as I find bugs in my code, I will create tests to show whether or not I've resolved that particular issue. So if we look at this, we can see that because of this kind of pattern of some sort of known inputs and some sort of known outputs, we can kind of make some tests like right out of the gate so that we can work on a problem and iterate on it and kind of see like how this is going to work, right? So, well, let's walk through that because we're going to kind of prepare with some basics, and then what I want to do is create some sort of command line utility that helps me fetch and retrieve this data particularly quickly, so that I don't have to like copy and paste it in, which kind of seems lazy. But I want to be able to start up a new day's project, like kind of pre-canned with some tests that I can manipulate and use moving forward. So what would I do with this? Well, I could go straight to the puzzle input, but I think that's a leap too far, meaning that I have some known set of inputs and I have some known set of test outputs here where I can test each individual piece first and make sure that I've got the values that I'm looking for. And then I can also test the overall score. So let's do that. So if I switch over to warp here, and maybe I'll do a follow-up video on warp. So if we dive into our Go folder, and I don't have a lot on this particular server, but a playground folder, I'm gonna make an Advent AOC folder for Advent of code, and we're gonna go into there, and we're just gonna start by bringing up a window in the main.go file. So what I want to do is again kind of hammer on this like TDD idea of, I'm certainly not going to be the fastest, right? Because I'm going to be doing a little bit of TDD here, but at the same time, my purpose is not to be fast, but to be complete with Advent of code. So we have function main, and if we were to run this, we're just gonna print. I like the loggers package, so I'm gonna use what I like. So Loggers is a package that allows us to do like different types of structured logging. It can be as easy or as complex as you want. But in my case, I do like it. Go mod init, go mod tidy, and then mod. Actually, I think now that we've done that, we can just do go get. No, I think get go get, and then this package right here. So this is a logging package. Like I said, you get a lot for free if you use it. Let's do that. Is it include? I probably have my syntax wrong here. Where's it import? No. Yeah. Okay. Go mod tidy. All right. Got our stuff. Okay. Typically in a work environment, I'd vendor this, but I'm not going to. I don't think that's necessary for what I'm doing here. All right, so we got a program, and so if we do go run main.go, it's going to run, and we're just going to knit git here so that we got some other things going on. Okay. So let's talk about TDD for a second. So if we go back to our advent code problem, which is here, we know that we're going to get a file with a letter that is multi-line, and each line represents a round of rock, paper, scissors, and there is a player A and a player B, or player 1 and player 2, and their throws of whether it's rock, paper, scissors is determined by a space. So we've got player 1 space player 2, and that this is some outcome of something. So I know that based on this line, the first person threw a rock, which is A, and then paper, which is Y, and that ended up with a win for you, which is the person who threw paper. Paper wraps rock, and we're playing. Our plays are the second player's plays, so we get a win score of 8. So that is 2 because we chose paper, and 6 because we won. We can go back up here and look at the rules that define that, but really we just need to look at this test subject. So we could do something where we can call something, we'll just make a function called score, and this will be scoring just an individual string, and we can return an int from that. And one thing that we can think about is how are we going to score this? Well, we're going to get some letter values, A, B, C, Y, X, Z, but really A just maps to 1, B to 2, and C to 3. And if you think about the way that we're going to do this, we can do 1 minus 2. Well, if it's a negative, the right person wins. Unless it's a difference of 2. So we can think about this in a very numeric way, and then we just map A, B, and C to 1, 2, and 3, X, Y, and Z to 1, 2, and 3, and then let the math decide who wins. But how do we function? How do we create a test for that? So we can create not a new folder, a new file. I also use VS Code. That's my preferred IDE. I realize some people are Vim elitists and may balk at that. I use Vim too. I just prefer this. So it's not that I can't, it's just that I won't. Okay, so we can do this, and then we can create a test func test score. That. And then that. And then I'm not sure if you're aware, we talk about testing packages. I find assert an amazing package to use. It helps me do testing very quickly. And so I'm going to use that. And so we can use this assert equal function, and we can make a call on some sort of value. So we'll call A space, was it Y? Let's look at our example here, A and Y, and our desired score is an 8. So we know that given that, we're expecting an 8. And in parentheses here, and what am I missing? Undefined score. We'll tidy that up. Okay. So we have the assert package. So now we can run this, and we run this test, and we have an example input, and then we have an expected, oh, I reverse those. I do that all the time. We have an expected value of 8 with an input of score, and right now score is 0. Now we could just leave this alone here, and that would be fine. But I like to, especially with something small and kind of tight like this, I really do like to use test-driven development. So we may do something like type test struct. Oh. Yeah, sorry, like that. I don't know what I'm naming. So what we're saying is, hey, we've got this anonymous struct, which we're going to define here in a second, and that is going to be our tests. And then so our anonymous struct is going to have our expected, which is an int, and then it's going to have, we can give it a name if we want, but we need input, which is a string, and so that's that. And then so we can simply do something like this, where our expected is 8 and our input is a b, and this is what we would refer to as like a test-driven development approach. So it seems a little overkill for what we're doing here, but will make sense as we add more tests. So we can say for t, or test range of tests, and we can simply change this now to be a little bit more generic. Assert t test dot expected, and we can do a score of test dot input. Okay, and so we can run this again, and we can still see that we get the same output. Okay, great. Now we're going to iterate on this, but before we do, we've got a couple of other test scenarios. So we've got b and x, which should be a score of 1. So we can do expected 1 input b and x, and then finally we'll add one more test, which is defined here, c and z, which the expected outcome of that is 6. So now we've got a couple of expected scenarios with their inputs, and we can now iterate. So I'm kind of going slowly through this, but it kind of shows you that we can create this iterative process of what our expectation is, what our actual score is based on the input. And so now we're doing like kind of real kind of TDD type stuff here. So now let's go back to our score function. Well, we know that when we get a string in, we could say we could do a bunch of validators here and maybe like throw some errors if the data is not in the right format. We're solving puzzles here, so we don't want to create a whole lot of slowdown, but we do want to like iterate through this. So what I can simply just do is do a strings dot split, and we know that the string is s, which is great. It's already set up for us. And we know that it's it's separated by a space, and so here are 2 values, and so we'll just call items. That's pretty straightforward, and we'll just say if length of items, because I don't like my program crashing, is less than 2, because we're expecting 2, then we're going to return 0, which may add some confusion later. Probably would rather return an arrow here, but again, we're just doing some test-driven development. So I can rerun these tests at any time, and again, no real change in our output. But we have our 2 values. So now what I want to do is a little bit of a map here, And so we're just going to create a play. We're going to create a map. I guess suppose because we're up here, you have to do it this way. We're going to do a map of string to int, and our values are going to be A1, B2, and C3. And then I'm just going to do X, Y, and Z for the same thing. X, Y, Z. Okay. So I don't like, we'll call it smap. Okay, cool. So now all we really need to do is get the play the numeric score is smap items sub 0 minus smap items sub 1. Okay. Now we could just return this and we're going to get a different value in our test, but I know it's not the whole answer. And in fact, we did pass one of our 3 tests. I'm going to pass the test.input as the message, just so you can get a clear idea of which ones we passed. So A, B, and CZ. So those 2 failed. So BX actually passed with a value of 1. So why was that 1 and 1? So let's look at the rules. So let's start implementing some of these. So if we assign a numeric value to rock, paper, and scissors, we know that if our value is equal to 0, it's a tie. So what do we do with the draw? The third round is a draw, with both players choosing scissors, giving you a score of 3 plus 3. So if we're at a draw, right, then we're going to take whatever both players chose as our score. So we can simply do this and say, if n score equals 0, then return. Probably not super efficient doing it this way, but man, I gotta do it. P1, P2. We know that if we're at a draw, P1 plus P2. Okay, cool. So let's rerun our test. All right, cool. We passed another test. That's kind of cool. Now, I suspect the first one was kind of by accident, but we're going to keep running with this. Okay, so we know that if this is true, then that's the case. So then, okay, let's look at this one last time. So we know that if A is 1 and player 1 is A and player 2 is B, that means our score is going to be negative, right? And if we have a negative score, then I know that player 2 won. If we have a positive score, player 1 won. But if we're off by 2, then it's the reverse. The reasoning is that rock always beats scissors. So if they're off by 2, whichever direction it's in, I believe the other team has won. So we can do this. If n score equals 1, -1, then we know that we won, and we won appropriately. So it should be +6 because we won, plus whatever we chose. So it should be P2 plus 6, right? So what happens if we go back to our test? Perfect. Okay. And now we're winning in all scenarios. So now let's go back to our example. In the second round, your opponent will choose paper B and you should choose rock X. This ends in a loss for you with a score of 1. So 1, which is what I threw, plus a 0. And I think this should just be P2. Let's run this test again. Okay. So I think this is our answer, okay? So if we do a score for a given line, then our answer should be that. So then we can create a function called total score, which receives a string, and we can do a lines equal. That's probably better reading a file, and we can talk about enhancing this further. But we can do a lines, and we can just say strings dot split, and we're going to take in our string, and we're going to do that on hard return, right? And then we can do a for line range lines. We'll do total score equals 0, return total score, and boom. And then we can simply do total score plus equal score line. Right? Seems pretty straightforward. And what's kind of cool about this is now we can take this same kind of example here and we'll do a test total score. And for our input's going to be a little bit different because it is going to be something like that. And this goes away. And we know that our expected score total is 15. So let's run it. Oh, there we go. Boom. Okay, so we know total score works. Awesome. So that's exciting. So we know that we have some sort of input, we have some sort of value, and we can test it. So here we're on this like test-driven development kind of concept. Now maybe there's an error, we could incorporate that. I don't think we're gonna have a problem here. So then the next thing becomes, well, how do we get this test file, right? So if we create a test.txt, just for example, and we go back to our browser and we get the puzzle input, we copy all of that and we bring it back in here and we paste it, we know that's our input, right? So we want to read this in. So now got a couple different options for that. os.open file. Let's see, test.txt, flag os. I can just do a read only on that. And then permissions. Oh. This is just a test app, so in this case, if I got an error here, I want to fatal it. It's been a while, guys. Hold on. Not open. Yes, I use Google. Was it read file? Oh, that's why. I was like, there's something wrong. I was like, there's way too many variables. Let's see. Oh, let's put the whole thing. Well, easy enough. Yeah, except I'm gonna change that to B because it's not a file. Stringify it, and then info F. There you go. So now I could have added the file input to a test, but not really necessary. If I go to the terminal and I go run main.go, I should get a value. So my value output here is 1,173. As you can see, I used some test-driven development, but let's see if we actually input this into our test here. Submit. Oh, that's not the right answer. Your answer is too low. Okay, so I have the value wrong. That's not it. So there is obviously a bug in my logic. So let's take some samplings here and let's see if we can understand the rules. So the mapping's fine. That's all fine. I'm pretty sure my issue is in the score. Unless for some reason I've got 2,500 rows and I've got, and it ends with AZ. I probably have all the input data. I could verify that, but I don't really think that's the issue. So AZ, let's look at this one. So AZ, that's probably one of those edge cases. So if let's think about the expected in a second, but the input is AZ. So that is a rock with a scissors. So I'm going to lose that, but because I picked scissors, my score should be 3. Right? Always forget the comma. Okay, so that's okay. Right? Okay. What happens if C and X, Y, Z? So that is they played scissors, I played rock. I should get 6 points for winning, and I should get a +1. Aha. I suspect this is my edge case. So let's look at our test input, see if it actually exists. It does. Okay, what did I do wrong with the logic? So they played a scissor, I played a rock. Their scissor is a 3, and my rock is a 1. So if we go into our test and we look at our scoring, 3 minus 1 is -2. We could probably change this to greater than or equal to, because I don't think we'll get any higher than that or lower than that. And if I run this test, what happens? B and X. So we knew this was right before, but now it's not. So B is what? B is a 2. We're going negative, not positive. Okay. That is the benefit. Expected 7, actual is 1. Okay. The end score is less than or equal to 1. Okay, let's think about the A and Z case for a second. X, Y, and Z. So that is C and X are similar. They're both similar, where C is 3, A is 1, X, Y, Z, that's negative 2. Where did... Okay, A is 1, which is rock, paper, scissors, Z. Okay, so A1 minus Z is negative 2, but we lost, so we want a 3. Okay. C and X. C is scissors, and X is rock. So this is actually coming out to a positive 2. Okay. That's what I was thinking. How am I thinking backwards? So if we run this again, so previously 11.0, now we're at 12. Let's just take a look. And don't really care how many submissions it takes here. It's the right answer. Answer's too low still. Okay, so I think I have a couple more of these edge cases that I haven't figured out entirely. So let's do this. Let's create a matrix of A's and all their counterparts and what the score should be. Right? So let's do A and X. So A and X, X, Y, and Z. So that should be 1, A and Y. So that is rock and paper. That is also a 1 because no, a 2 because we lost, but we played the second. And then A and Z, which is rock and scissors, we lost and played the third. No, this one should be 8, right? We're gonna focus on this real quick. So A and X, expected 1, but its actual is 2. So if we look at our map, if the score is a tie, Okay, let's go back and look at our rules. It's a draw with both players choosing scissors, giving you a score of 3 plus 3 is 6. Okay, so the test is right. My expectation is wrong, rather, with the test. So that should be the answer. Okay, perfect. So now we can repeat this for B. B, B, and B. So let's think about this then. So we've got paper and rock. So that's a loss for player 2. And they are running a 1. You've got paper and paper, which would be a 2. And then you got paper and rock, which is a 1 plus 6 is 7. Okay, and then you've got paper and scissors. I'm sorry, that's 1. Paper and scissors. Scissors beats paper. So this is a 10, right? Because it's 3 plus a 6, which is a 9. I don't know where I got 10 from. That was a mistake. Okay, and then what about this condition? Expected 2, actual 4, it's B and Y. So that is rock and rock, which is a tie, which should be a 4. Okay. Okay. So you got scissors and rock. Rock wins. That's 7. Scissors and paper. Paper wins. That's an 8. Scissors and scissors. It's a 3. Right? C and Y. Okay. So that is C, which is a 3, which is scissors, and paper. Scissors beats paper. So this is a 2. I'm not thinking straight. Okay. So this is scissors and scissors, which is a tie, which makes it a 6. I mean, my logic is checking out so far. So this is every iteration of left play versus right play. All right, so we've got rock versus rock. That should be a tie. That should be a 2. We've got paper versus rock. That's a loss. That should be a 1. We've got scissors versus rock. That should be a 7. Right? We've got rock versus paper. That is a win. So paper beats rock. That's 2. So that should be 8. We've got paper, paper. That's a 4 because they're both 2s. And then you've got scissors beats paper. And so this should be a 2. I don't know what the issue is. We're going to keep going. All right. So, rock versus scissors. It's a loss, but we're 3. Okay. Paper versus scissors. It's a win for me. That's a 9. And scissors versus scissors. It's a tie. It's a 6. Okay, am I missing a rule? Example, if you were to follow the strategy guide, you would get a total score of 15, 8 plus 1 plus 6. The first round, okay. Plus the score for the outcome of the round. 0 if you lost, 3 if the round was a draw, and 6. 3 if the round was... Hold on. 3 if the round was a draw. 6. 3 if the round was a draw. That's the outcome of the round. Oh, did I? Should have read the rules, right, guys? I think what that means is that this, if it's a draw, is not that. It's a 3 plus whatever you score, which means my tests are now probably off by some significant value. Because I don't want to change all my tests in this case, I'm just going to run this and see if our output is higher, which it is, and then I'm going to plug it in and test it. That's right. Okay, great. So we've successfully completed round 1. This took a little bit longer than expected, but I was trying to be meticulous and going through the process, and you can see there were some failures because I didn't read all the instructions. I'll be sure to do that next time. It cost me some time when I made the assumption that it was just, if a draw, it was combining the scores, but in fact it was just a 3, or that was the point value for a draw, followed by whatever your individual play was. So as you can see, this is can kind of be fun. There's a second part to this challenge that we'll go through here in a little bit, but that was pretty entertaining for me. So let's go back and fix our tests. In this case, we know the values are right. So AX, for instance, this one should be a 4. And then if we find BY should be a 5. BY should be a 5. And then let's see here. AX should be a 4. Did I duplicate some of these? And BY should be a 5. I guess I did. Oh well. Right. So those are all cut up. But yeah, as you can see, advent of code is pretty fun. As you unlock each piece of the story, it reveals a picture, and it kind of is a way to hone your skills during the Christmas holidays. I don't know about you, but in my work environment, things tend to slow down towards the end of the year. Things quiet down, things slow down. And so it's a great time to hone your skills and get ready for your next coding adventure. Until next time, I'm out.